Okay, so we're going to work through this paper, and just a few things to note on the front. Firstly, you get 60 minutes of paper. That's 100 and 100 marks, so you need to be kind of working at more than mark a minute, kind of ideally trying to do 2 marks in a minute. Also, this bit here that says that you should give your answer to 3 significant figures and that you should use the pi button on your calculator. Okay, so those are all important things just to bear in mind. And now let's straight on with the question. So, firstly, work out the value of this on our calculator. So we type in and we make sure that the square root is on the top. So we're going to type in the square root button first. 90.23 plus 54.1, and then actually on my calculator, if I do that, it's better if I put the fraction button in first and then the square root, so that the square root stays on the top. 90.23 on the top plus 54.1. And then on the bottom is not in the square root, 5.75. Okay, and I'm going to write down kind of everything that's on my display. So that's 2.089346458. Write your answer correct to part 1, correct to 2 decimal places. So that's 2 numbers after the decimal point. So I'm thinking that I want to cut it off here, and I look at the next number, this one here. I think, does that round up or do I stay at an 8? So is it closer to 2.08 or 2.09? And because this is 5 or above, it goes to 2.09. 2 significant figures, well, that's kind of 2 numbers basically, and in this case, so we're going to have 2.0, and we would cut it off here for 2 significant figures. So now we look, does the 8 round it up or not? Again, it does, because it's 5 or above, and it becomes 2.1. The only exception when this kind of is not just 2 numbers is if there are a whole load of zeros. So 0.00002, those zeros at the front wouldn't be significant. Likewise, lots of zeros at the end where they're just placeholders wouldn't be significant. Otherwise, zeros in the middle like this one, they are significant. Okay, let's move on. So write down the prime numbers in this list. Okay, so this is something you need to know. 1 isn't a prime number, but anything that it can be divided into the number other than itself and 1. If it's got something that can be divided into other than itself and 1, then it isn't prime. So let's go through them. 6, yep, that can be, it's got 2 as a factor. 7, that doesn't. Okay, so we can write down 7. 19, that doesn't have anything. No factors that go into 19 other than 19 itself. 49, I know 7 7s are 49. 99, I know that 11 9s are 99. 100, 10 10s, so that's that. And then 2, so 2. So not 1, but all of those ones. Write down all the square numbers. So something times something, square numbers, because they kind of make a square. Something times something, so it's the same number each way. 6 doesn't do it, 7 doesn't do it, 1 does do it. 1 times 1 is 1. 49 we know is 7 times 7, we've said that one. And 100 is 10 times 10, so those are the options there. Okay, Jane is given a number at random from the list. What's the probability that Jane is given an even number? So an even number, so 6 and 102, so that will give us 3 as a fraction, so that's 3 out of 8. That can't be simplified. A multiple of 3, 6 is a multiple of 3, we know that. 19 isn't. 49, we might not know whether that is. A quick way that we can check whether it is, we can add the digits up. 4 plus 9 is 13, and if that's a multiple of 3, then it is, and if it isn't, then it isn't. So that's not, whereas 9 plus 9 is 18, and therefore that is, because 18 is a multiple of 3, and 100 isn't, and 2 isn't. So we've got 2 of those. So 99 is and 6 is, so that's 2 out of 8, which equals a quarter. Factor of 300, so does it go exactly into 300? Well, we've got a calculator, so we can test them all out. 300 divided by 6, does that go exactly? Yes, it does. Okay, 19, well, we can just go through minter. Divided by 7, no it doesn't. 1 does. 19 doesn't, 49 doesn't, 99 doesn't, 100 does, and 2 does. So we've got 4 that do, 4 that don't, so 4 out of 8, which is a half. Brian is using boxes, so my just slipped off the top of my page there. I can't see what's. There we go. Brian is storing boxes containing his belongings. The box he's using look like this. Work out the volume in cubic meters. Okay, so cubic meters. So that's your clue here. So rather than converting at the end, it's much easier to convert at the beginning. So we're going to go 0.7 times 0.6 times 0.5, and I'm writing that in, and then I just do that in my calculator. 0.7 times 0.6 times 0.5 is 0.21. 0.21. If you do it the other way around, your conversion has got to be divided by 1,000,000, because there are 1,000,000 centimetres cubed in a metre cubed. So if you go 70 times 50 times 60, you've then got to divide by 1,000,000 and you'll get the same answer. Okay, how many of Brian's boxes can fit in the shed? Okay, well, let's assume they're going to fit nicely and keeping them that way round. So how many fit along that way? Well, 60 centimetres, 240 centimetres, we're going to fit 4 along that way. We're going to fit 50 centimetres and 2.5, that's going to fit 5 of them. You can do 250 divided by 50 if you're not sure about that. And then going high, well, that's 280 divided by 70, or 2.8 divided by 0.7. And again, that's 4 high. You'll be able to stack them. So 4 times 4 times 5. I can probably do that without a calculator, but let's just do it. So 80, let's just write down the sum that we've done. 4 times 4 times 5 equals 80. Okay, Brian hires a quarter of the space in the shed to store his boxes. Jim charges him £1.50 per day for each 1 metre cubed of space he hires. Brian stores his boxes for 3 weeks. How much will Jim charge him? So Brian hires a quarter of the space in the shed to store his boxes. So a quarter of the space. So a quarter. I've done this differently. So this is going to be a quarter times what way around should we do this? Quarter times the volume of his shed. So it's a quarter times that, or that divided by 4. So 8 times 2.4 times 5 divided that by 4. So it's 4.2 meters cubed. That's how much his Hired. £1.50 per day for each metre cubed, so £1.50 times by the 4.2. We let the math sort out the decimals, and it's times 3 weeks. So 3 weeks in my calculation, that's 21 days. So 4.2 times by 1.5 times by 21 days is 132.30. There we go. The train from Addington to Takitov the train travels in 2 hours 15 minutes. If these towns are 135 kilometres an hour, what is the average speed of the train in kilometres per hour? So we've got a calculator, so we can kind of make that work for us. We want speed, so we want distance divided by time, but with kilometres per hour, so we want this time in hours. Now they've given us quite a nice time, so it's how many hours? It's 2.25 hours, so 2.25. If you've got a calculator, you can even do the division with your 2.25 there, but 2.25, because it's a quarter, is 135 divided by 25. That gives you 60 kilometres an hour. Okay, so yeah, does that make sense? Yeah, 2 hours would be 120, and then quarter an hour more would be another 15. So that makes sense. Jane's rally car completes a 5 kilometre lap of a circuit at an average speed of 120 kilometres an hour. How long does it take to complete one lap? So time. So if you're using a Dunn-Silly triangle, time is distance over speed. So distance divided by speed is 5 divided by 120, which is 0.416 recurring hours. So if we time that times by 60, we get that's 2.5 minutes, which we're going to write as 2 minutes and 30 seconds. Now there is a neat little button on your calculator that if you press, so when you get this answer here, if you press the button that has a kind of degree symbol, a dash symbol and a double dash symbol, if you look for it, there's a button on your scientific calculator with that. If you press that at that stage, it will convert your number of hours into a number of hours, minutes and seconds. Okay, and it will do it in one go for you, so you can press that button. Have a play with it, see what you think. It's quite useful. It's worth knowing how to do this otherwise, but as a check, it's really quite useful. Okay, Mark completed a running race. Completed a running race in 1 hour and 12 minutes. His average speed for the race was 17.5 kilometres. What distance has he run? So distance is speed times time. So we've got 17.5 times the time, which is 1 hour 12 minutes. But so we want to turn that into that. Now this is what I was saying, you can turn it into a fraction like that, or you can see it as 1 1/5 or 1.2. But this method works for any number of minutes. Okay, and then we can just put that into our calculator, because it's 12/60ths of an hour. So 17.5 times, use the kind of shift fraction button if you want to do this, 1 and 12/60ths, and that gives you 21 kilometres, which again, that makes sense. How far did he go? He's going 7.5 kilometres per hour, and he's going a bit more than an hour, so 21 kilometres. Tom is taking part in a driving contest. Diving contest. Each dive is awarded a mark out of 10. After 8 dives, his marks are as follows. Write down the modal mark. So the modal is the MO here that I'm looking for, the most common. So the most common, you've got 8.6, 8.6. No other mark came up twice, so 8.6 is his modal mark. The median mark so far. So for that we need to put them in order. So 8.5. Oh, there was a 7.9 at the beginning. So we're going to cross off the 7.9, the 8.5, 8.6, 8.6, 9.3, 9.7, 9.8. So we're going to go for the middle. So kind of with your fingers you can kind of cross off the ends, or you can go cross them off together. So I'm just going to underline them. Not that one, that one. Not that one, that one. That one, that one. One, 2, 3, 4, 5, 6, 7. I've only got 7 marks. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I've missed one off. Okay, so I've missed off a 9.6, so we'll put that in there. There we go. So it's there. So our middle ones. Oh, that's a bit messy. Let's just write this out properly over here. We've got loads of space. So it's now 7.9, 8.5, 8.6, 8.6, 9.3, 9.6, 9.7, 9.8. Not that one, 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 not that one. So there's 2 in the middle. We've got the median of those two, we add those two up and divide by 2. Or we look for what's between those two. 8.6 plus 9.3 divided by 2. So that answer is 8.95. And we don't round that, it just stays like that. Work out the total of his 8 marks. So we've just got to add them all up, make sure we don't make a mistake. 7.9 plus 8.5 plus 8.6 plus 6 plus 9.3 plus 9.6 9.7 9.8 72. His mean mark so far, 72. Mean is the total divided by the number of marks, there are 8 marks. So 72 divided by 8 will give me 9. On his 9th dive, he makes a mistake and is awarded 4.8. What is the total of marks for the 9 dives? Well, we just add that on and we get 76.8. So 72 plus 4.8. 76.8. Tom needs a mean mark of 8.5 for his 10 dives. What mark does his 10th dive need to achieve this? So, well, his total, they've given us a clue, his total, they've been working on his total, needs to be 8.5 times 10, which is 85. And his current total is 76.8. So 85 minus 76.8 is minus 76.8, 8.2. So he needs to score 8.2 and then get the right total to be able to get the right mean. I hope we're all with us. Do stop the video at any time and go back and replay anything that you're not sure about. Five pupils are going to take part in an egg and spoon race. The probability that 4 pupils winning the race is given on the table below. What's the probability that B will win? Well, there's only 5 people, so somebody must win. That's the assumption that they're going on. 4, 5, 12 so far. So there are 3 left. 3/15ths left. So we've got, because it must add up to 1, so 1 minus 12/15ths is going to give us 3/15ths. Who's least likely to win the race? Unfortunately, that's Danny. Only 1 out of 15. Usain is running the 100 metres at the Oslo Games, and his coach says the probability of Usain winning is 0.95. What's the probability of not winning? Well, we've got to make that up to 1. Probabilities add up to 1, so 1 minus 0.95 is going to give me 0.05. 1 is the total probability they must add up to. Jan is competing in the javelin against Barbara. Sue thinks the probability of Jan winning is 0.35 and Barbara is twice as likely to win as Jan. Well then Jan, if Sue's right, correct, Jan, Sue thinks that the probability of Jan winning is 0.35. Barbara is twice as, so Barbara equals 0.35 times 2, which is 0.7. Total probability is 0.7 plus 0.35, which is 1.05. Which is impossible. There we go. Okay, we're going to enlarge the shape by a scale factor 2 using the eccentric enlargement P. Okay, so the easiest way to do this is to kind of pick one of the points, potentially a nice one here, and that's 2 squares away. We're going scale factor 2, so this point has got to be double the distance away. So this point has got to start here, because that's double the distance away, and then we draw the shape double the size. So was there, it's now going to be up there. Okay, and then it was there, down there. We get our ruler out and we draw that a lot nicer than I've drawn it. Apologies there. Okay, the other way that we could do it is that we could go here and go down 3 and across 4, and that means to get to the image point we go down 6 and across 8. Okay, and you could do that with every point and then join up all your points. Okay, so we've done that. What is the area of shape A? So we've got a triangle here. We can do triangles. So 2 times 3 halved, so that's 1.5. You've got 1.5, 1.5, sorry, yeah, 2 times 3, so 2 times 3 halved is 3. So 2 times 3 is 6, halved is 3. So that's 3, 3, 3, and 3. 4 3s are 12. Or if you remember your formulae, then this is the product of the diagonals halved. Okay, so 1, 2, 3, 4, 2, 3, 4, 5, 6. So 6 times 4, and then halved. Okay, so either one of those is fine. What is the ratio of shape A to the area of shape B? Well, two ways you can do that. You can either say, okay, I'm going to work out the area of this one. So this one is going to be, rather than 4 across, is 8 across, rather than 6 is now 12. So 8 times 12 is 96, and you can go that, well, the ratio is going to be 12 to 96, and I know that that's goes in 8 times, so that's 1. Sorry, 12 times 8 halved. I was thinking that was gone wrong. Is 48. That's 12 to 48, which is 1 to 4. Or you can just know that because the lengths are in the ratio 1 to 2, then the areas are in the ratio 1 to 2 squared. Yeah. If shape A is enlarged by scale factor 3, what's the area of the enlarged shape? Well, let's use that new fact that we found. We know the ratio will be in the 1 to 3 squared, which means it'll be 9 times bigger. So we're just going to do 12 times 9. We're not going to even draw it. And we're going to say that it's going to be 108 centimetres squared. Onto a bit of algebra. 4a minus 7b minus a plus 11b. So we're going to collect the a's together. 4a minus another a is 3a's. We've got minus 7b, so the sign goes with it a bit before. So minus 7b plus 11b is going to give us plus 4b. 3c squared, but it's the 3 and the c are squared, so 3 squared is 9, c squared is c squared, times 4c, which equals 30, sorry I've written that on the line, 36 is the numbers, c squared is c times c, times another c is c cubed. 56 de over 7, so we're going to divide the numbers, so we get 8, and it just stays as 8de. The 7 is not, you divide by one of the things, not everything. Multiply this out, so this is 7 lots of x and 7 lots of 2. So we can write that down, 7x plus 14, don't forget the 14. This one we're going to have to do in a couple of stages, so 12x plus 8 plus 7x plus 14. They'd be nice to us that have kept it all positive. It's going to be 19x plus 22. Factorise, that means put in brackets and take as much out, so as big a number as we can that goes into 18 and 27. 6 doesn't, so I think 3 does, but 9 does as well, so we'll take 9 out. We're left with 2y, because 9 times 2y gives us 18y. What gives us 27? If I times by 3, I get 27. Okay. Continuing with some algebra, some equations this time. Something divided by 5 equals 10, so therefore we've got a times by 5, times this side by 5 we get x, times this side by 5 we get 50, and you might put over here a little times by 5 to indicate that that's what you've done. Okay, so that's going to be x is 50. Here, what have we got to do to get the y's on the end? Well, we're going to take away 18 to begin with. We're going to take away from this side. Just get 5y. Take it away from this side. We get 23. We get 15. And then we've got to divide by 5. Got 5 times something is 15. Divide by 5. There we go. Y is 3. Let's just check that back in. This is a slightly trickier one, so let's just check it back in. 5 lots of 3 is 15, plus 18 is going to be 33. While we're at it, let's just check this one. 50 divided by 5 is 10. Okay, and this one, 2 ways to do this. Most people tend to prefer the multiplying out first, so 12z minus 4 equals 0. Yeah, that's my z's. So 12z equals 4 if you add 4 to both sides. So z, we've got to divide by 12, is 4 divided by 12. We can just write it in a fraction like that, which is quite neat. 4 divided by 12 is 1 over 3. So the answer is 1/3. You can write it as 0.3 recurring, but you must have the recurring on, otherwise it's not correct. 3w plus 17 equals 11 minus 3w. So we're going to get the w's all onto one side, so we're going to add 3w to both sides. We get 6w plus 17 equals 11. So we're adding 6w, so we're adding 3w. So we're going to go 6w, we're going to take 17 away from both sides. And we're going to take 10 away, minus 6. And so w we're going to divide by 6 is going to be minus 1. Divide by 6 is minus 1. You might write down a number when he multiplies it by 3 and adds 2, he gets the same answer as when he adds 4 and then multiplies by 2. Okay, so when he takes the number, multiplies it by 3, that's 3x, and adds 2, and that equals the same as when he adds 4 and multiplies it by 2. So this is the one you might not have guessed. Put it in brackets and multiply by 2. Okay, so then we've got to solve this. 3x plus 2 equals 2x plus 8. So move the x's over there, so you get, take away 2x, you get x plus 2 equals 8. Take away 2, x equals 6. There we go. Moving on, I hope you're still with us. So, with the centre 0, 0, rotate shape P through 180 degrees. Now we've got to draw on the shape P first of all. Okay, there we go. Plot the points 4, 4, 5, 1. Can I just enjoy the technology that I'm using here, because I'm using one of the new Chromebooks, and the precision with which I can write on this is really quite special. I should probably get a ruler out, but there we go, we'll just go freehand for now. Okay, and now we're going to rotate this through 180 degrees, so that's P, about the new shape here. So at this point I'd get my tracing paper out, I'd rotate it around, and I think I'm going to try and do it, which is always risky without doing that, so this one's going to end up That's 5 over here. Then this one is going to end up here. Let me join those up. Do you get your tracing paper out to check that I've done that right? That's right. Draw the line y equals -1. Well, there's y. Let's do this in a different colour. Y is here. Y is -1 here, but it's also -1 all the way along here. Reflect chain P in the line y equals -1. So we're going to reflect it over here. I don't think we had any problems with this. Okay, and there's the new shape. Oh. Translate P, 6 units to the left and 2 units up. So 6 units to the left, let's go in a different colour. 1, 2, 3, 4, 5, 6, and 2 units up, 1, 2. So that's going to be a new corner. 4. No, that's not so neatly drawn. Label the new shape S, but let's just check. 1, 2, 3, 4, 5, 6, and 2 units. Okay, there we go. Okay, now this tends to be the trickiest bit. Describe fully the single transformation which maps Q onto S. Now, without some tracing paper, this is a bit more difficult, but I think that looks like a rotation. It looks fairly symmetrical about this point here. So I think if we rotate, so describe the transformation, we've got to rotate it. How far? 180 degrees. We don't need to give a direction because it's 180. And what's the centre? The centre is the point as a coordinate -3, 1. Again, if I've made a mistake, please let me know, but that looks like that's what it is. So, onto some geometry. And the shape shown is a regular pentagon. Calculate the size of each of the angles marked X and Y. It's a pentagon. The exterior angle is always out to 360, so a pentagon has 5 sides, so 360 divided by 5 is going to give me 72, which means that's 72, which looks about right. And it's a regular, so they're all the same size, so that one will be 108, which means Y will be 108 because they add up to 180. So X is 72, Y is 108. This pentagon is not regular. Work out the size of the angle marked Z. Well, if it's a pentagon, then they all add up to the same thing. And you might know that a triangle adds up to 180, a square to quadrilateral to 360, and they keep going up in 180. So a pentagon is 540. You might know that you've got n minus 2, the number of sides minus 2 times 180. So 5 minus 2 is 3. So 5 minus 2 times 180. So 3 times 180. So that's 540. Or you might go, well, it's the same as in a regular shape, and in a regular shape the interior angle is 108, and there are 5 of them, so that's 540. There's 3 quite different ways that you can get to 540. So now we've got to do 540 minus all of this lot, so minus 32 and 102 and 90 and 152, which in my book, with a little help from my friend the calculator, Okay, diagram below shows the part of a regular polygon. Work out the number of sides of this. Well, we need to go into what the exterior angle is going to be, because it's much easier to work it out from that. So the exterior angle, 156, 180, take away 156, is 24, is that right? 24. And then how many 24s are there in 360? Because there's 360 is all of them. So I think that's 15, but let's just check. 360 divided by... That's 15. So there are 15 sides. Okay, because each of them has got to add up to 300. Each of them has got to add up to 360 in total. Each one's 24, so 315. Okay, we're closing in. Last few questions. Let's keep concentrating. Diagram shows a bicycle wheel. Radius 0.35 meters. Calculate the circumference of the bicycle wheel. Well, we all know that circumference. Circumference is pi d, and the diameter is twice the radius, so pi times 0.7, because that's double that. And we're going to use the pi button on our calculator. Times 0.7. And we're going to write down, we press S to D, so we write down 2.199114858, and then we're going to round to 3 significant figures. So that's 2 point, we round after there, that 9, that's a bit of a pain, so the 9 means we've actually got to shift the next one on as well, so this becomes 2.20. There we go, change colour halfway through, 2.20 meters. Okay, let's go back to blue. Mary cycles from one end of her street to the other. If the wheel completes exactly 150 revolutions, how long is the street? Well, 2.2 is all the way around. 150 times your 2.19. Always go back to your original answer here. Just means your answer is more accurate. So times that by 150, that's already in my calculator. Is 300 to 9.867 to 3 significant figures is 2, 3. Again, we've got another 9 that rounds up, so that's going to be 330 meters. Okay, and then this bit, a square of side 10 centimeters contains 2 semicircular shapes. What is the area of the shaded section? Well, they're 2 identical semicircular shapes because look, they start and finish at the same point. So 2 semicircles make up a circle. So we need to find the area of the circle and the area of the square and take them away. So the area of the square, that's easy. So it's 10. It's a square, so it's 10 by 10. It's 10 by 10, which equals 100. Area of the circle, which is the whole thing, is pi r squared, so pi times an r is the radius, that's only half of that, 5 squared, which is 78.5398. Okay, and so we take that away. Shaded equals 100 minus 78.5398 is 21.4601. We're going to round that to 3 significant figures, so we're going to call that 21.5. 5. There we go. Okay, pie charts. So the key to pie charts is how many 1 is. So there is Frank won 1.5 times the number of medals that Hannah won. So this is 6 times 1.5. That's 9. And James won 1/3 of the number of medals that Hannah won. 1/3 of Hannah is 2. And that should come to 24 if we've got it right. 10, 15, 24. Good. No one else won a track medal. Draw a fully labelled pie chart, show the number of medals won by each of the 5 pupils. So, there are 24 medals. So each medal, this is the key bit of working, each medal is your 360 degrees divided by the total number of people, so in this case 24, which is 15. So each medal is 15 degrees, which means that each person, so this one, forget that bit of working, we've done that now, is 9 times 15, 4 times 15, 6 times 15, 3 times 15, 2 times 15. So as long as we've done this correctly, these should all add up to 4 times 15, 60, 9 times 15, 45, 90, 135. If we've done this correctly, it should add up to 360. Let's just check, because I've done that mental arithmetic very quickly. Comes to 360, so I know that I've got it right. Okay, and now I'm going to draw this on. I'm just going to use my protractor over here, which I hope will do this without causing too much grief on the screen. There we go. So I'm going to measure around 135 from there. There's my mark. Then another 60, so that's actually 195, so 5 degrees beyond the straight line. No, 15 degrees beyond the straight line. Then I'm going to go 30 from this side. And 75 from this side. 75, so I think it should be there. Should be a right angle, which looks like it's, that's all encouraging. So that'll be Frank, Jill, Hannah, Ian, and if you've got, there's a mark out here. Probably a good idea just to put the number of degrees in here. So this is 135, 60, 90, 45, and 30. Okay, we're still on the pie chart. Kim won all 6 medals in the field events on Sports Day. Pie chart for all track and field events, and what angle would represent Jill's medals? Oh, okay. So now the total medals is 6 plus 24, which is 30. So each medal is now 360 divided by 30, which is 12. So Jill, how many did she won 4. So Jill is 12 times 4, which is going to be 48 degrees. Final question. From A, the pupil runs on a bearing of 60 degrees for 3 kilometres. Now, this is going to be a reduced paper, so it might not fit on here, and obviously me doing it on the screen this bears no resemblance to what you might do, but the angles should be right. So 60 degrees, there we go, there's my 60 degrees. So 60 degrees, I measure it from A, it's going in that direction, using a scale of 1 centimetre to 0.5 kilometres. So that's going to be 6 centimetres. So say 6 centimetres for me is over there. Draw a north line at B. So let's do that. There's a north line at B. Mr. Farah is waiting on the finish line 2 kilometres due south of A. 2 kilometres due south, so let's call that, that's due south. So that's F. That's the point F. Due south. The pupil now runs straight from B to F. So we run this bearing down here. What is the bearing of F to B? So I can measure that. So I'm measuring all the way around clockwise, so I've got 180 degrees plus another, well, for me it's another, so it's 225, pretty exactly. Let's go 225. I would imagine you're going to get plus or minus 2 degrees on that, so 223 up to 227. If Daisy runs at a steady speed of 15 kilometres an hour, how many minutes does she take to run from A to B to F? Okay, final question. A to B to F. Well, we need to work out how far F to B is. So, me using my scale, I make that 7.2. So, oh, sorry, I make that, yeah, so that's 3.6 kilometres, so it's 3 kilometres plus 3.6 kilometres is 6.6 kilometres, and time is distance divided by speed, so 6.6 divided by 15 is 0.44 hours, which if I times by 60 is going to give me a number of minutes, which is 26.4 minutes, so I'm going to call that 26 minutes, I'm going to call that 26 minutes, or I can use my fancy button that we learnt earlier and said that's 26 minutes and 24 seconds. Okay, but 26 minutes would be close enough. Okay, and there we are done. I hope you enjoyed that. Please do review any questions that you want to go over. I just want to add in what the mark scheme says, because obviously I've done this not to scale, so I thought it would just be useful just to add in what the mark scheme says for this. So you get 215 to 218. So actually mine wouldn't have been accurate enough. So 215 to 218, anywhere in that range would get you the marks. And for the last one it was 29.4 minutes. Again, the principle is exactly the same, but as long as you can show you're working, they made it around 29, as I said, slightly too precise, but 29. 29 minutes there. So if you got around 29 minutes, then you're as accurate as they were. Okay.